Hello and welcome back. In this video we will be looking at equations. So an equation is any statement that's going to say that two things, generally numbers, are equal. So for instance, we have one equation on this side which says that 1 plus 1 is equal to 2. This is true. We know this. So 1 plus 1 is a number, 2 is a number, and specifically, there is an equal sign, so this is what makes this an equation. So 1 plus 1 is equal to 2. Over here, we have another equation, but this one uses some variables. We have an x and a y in it. So we don't know what x and y are, but this equation is asserting that 4 times x squared plus 1 is equal to 17 plus y. Again, 17 plus y is a number because y represents some number. We don't know what it is, but we can add numbers together to get numbers. Over here, x is again a number. If you square a number, you get a number. If you multiply it by another number, you get a number. If you add a number, you get a number. This is just a number is equal to a number. So that's all an equation is. So let's look at an example. So here we have an equation that's given to us. So we're told that y is equal to 3x squared plus 1. And we're also told that x is 5. Another way to phrase this is x is equal to 5. These mean the same thing. So the question is, what is y? Well, if we know what x is, we can plug 5 into our formula here, into our equation, and figure out what y is. So we know that y is equal to 3 times x squared. And rather than just plugging a 5 in there, so one of the dangers here is that if I just put a 5 there and I square it, it looks like I've written the number 35. But I don't want to write the number 35. What I'll do is I'll put parentheses around the number that I'm plugging in, so that I know that I'm squaring the x. And if I don't write a symbol here, if I just write the 3 and the 5 squared next to one another, it means we're multiplying them. So it's going to be 3 times 5 squared, and I can't forget the plus 1 at the end. So as I do this, I have to do this in a particular order. So here I will take the 5 squared first, because it's 3 times x squared. So 5 squared happens to be 25. And I can't forget the plus 1. And if I have 3 25s, well, that's 75. And then I will add 1 at the end to get 76. So y, my final answer is that y is equal to 76. Now I did things in a very particular order here. I did the exponent first, and then I multiplied, and then I added. Well, it turns out that there is a correct order to do these things in. This is called order of operations. So we'll come back and we'll look at another example in a second, but I quickly want to look at order of operations. So when we look at order of operations, we always want to resolve anything inside of parentheses first. The parentheses essentially mean do this first. So anything inside the parentheses, that's what we want to do. Next, we want to take care of any exponents that we see. Once we've taken care of all the exponents, once we've simplified all of those, then we do all of the multiplication and division. And again, there's a very particular order to this. We just go from left to right. So whatever the first thing that we see being multiplied or divided as we go from left to right, we do that. We continue going to the right. We'll do whatever multiplication we see, whatever division we see as it comes up. After all the multiplication and division is done, the only things left to do will be addition and subtraction. And again, we just go from left to right. So it's whatever addition or subtraction pops up first, and then we keep going over, and then we do the next one, and then the next one until there's nothing left. So again, when we come back and look at what we did here, when we had our initial expression on this side, we took care of everything in parentheses first. Well, if it's just 5, we can't really simplify that anymore, can we? So then we had some exponents. So we took 5 squared and we got 25. There's no more exponents, so we move on to multiplication and division. We're multiplying here, and now there's no more multiplication and division. The last step is just to do all the additions and subtractions. So let's do the next example. We've got y is equal to 5/6 x to the third power plus 1, where x is going to be 2. So we want to know what is y when it's rounded to the nearest hundredth. So again, we have our equation, and we know what x is. It's just going to be 2. So let's plug that in and see what y is. So y is going to be 5/6, 2 to the third power plus 1. Again, the things inside the parentheses, we can't simplify 2 anymore. It's just 2, so we're done with that. Next, the exponent. So let's simplify this exponent. 2 to the third power, if I write that over here, 2 to the third power is just going to be 2 times 2 times 2, which is 8. So it's going to be 5/6 times 8 plus 1. Again, when we look at this, we see some multiplication. So I'm going to have to multiply this together, and then we will add 1. So let's come over to our calculator. So this is Desmos, and I'll provide a link to this. And what I can do is in this calculator, I can take 5 divided by 6, and I can hit enter, and that provides us with 5/6. This is 5/6 as a decimal, and it's important that we don't round until the end of the question. You never round until you have your answer, and then you can round. So right now I don't want to round at all. So this is 5/6. The way that I can get 5/6 on the next line is I can click answer. So what this does is it takes the previous line and sticks it here. So this is my 5/6, and I can take this times 8. I hit enter, and this is what 5/6 times 8 is. It's going to be 6.6666666 forever, and it looks like it's rounded here. Okay, so when I come back to here, I know what 5/6 times 8 is. That's just in my calculator, and then what I'll do is I'll write it down, noting that I'm not writing down the whole thing. So this is going to be 6.666, a bunch of them. And I'm going to add 1 to it. So I'll come back to my calculator. I'll take the previous line, which is answer, and I will add 1. And when I hit enter, this is my number. So it's going to be 7.66666 forever. But our question asks us to round it to the nearest hundredth. So when I do that, I'm going to take 7.6, and then I have to look at the next digit, and because it's 5 or bigger, I round up. Oops. So this is going to be 7.67. So here is my answer. I like the calculator. Desmos it does everything that I really need it to. This is a good option. So here again we saw our order of operations. One thing to note is that if we have fractions, the numerator and denominator, the top and bottom of the fractions, have some hidden parentheses. So if you ever see a fraction, you can put parentheses around the numerator, around the top, and around the bottom. And this is more or less what the fraction should be. We won't see this now, but it may come up later. So it's just something to be aware of. There are some hidden parentheses in fractions. So let's do just another example. So let's let y be equal to 7/5 x to the 4th minus 16, where x is 3. And again, what is y rounded to the nearest, in this case 10th? So let's take y, and let's plug in our value for x. This is going to be 7/5 times 3 to the 4th power, and we're going to subtract 16 from that. Okay, so 3 to the 4th power, 3 times 3 times 3 times 3. Maybe I don't know what that is off the top of my head, so I can come back to the calculator and I can type in 3 raised to the 4th power. So you can see I have 3 raised to the 4th power. And if I hit enter, it gives me 81. Perfect. So I can come back and I can take 7/5 of 81 and I'll subtract 16. Cool. So now I need to take 7 divided by 5 and take it times 81. So I will take 7 divided by 5, enter. So that's 1.4 exactly. So then I can take 1.4, so by clicking answer, it'll duplicate whatever the last one is, times 81 will give us 113.4. And that we're not even rounding there. So we've got 113.4. And we're going to subtract 16. And again, I can come back to the calculator. If I want 113.4 is the last thing there, so I can click answer. And I will subtract 16. Enter. Gives us 97.4. Which luckily is rounded to the nearest tenth already. So I don't have to do anything. And there is my answer. Cool, so plugging in a number works exactly how you might expect. So the next thing to do is to look at adding and subtracting multiples of x. And what I'm going to do is I'm going to start with the rather silly example, but I think this will help. If I have 5 apples and I add 3 more apples, I have 8 apples. This is really, really simple. There's not a whole lot to be explaining. However, when we have variables, these work in the same way. If I have 5 times x plus 3 times x, one way to think of this is I have 5 x's and I have 3 more x's. So ultimately, I'm going to have 8 x's. So when we have multiples of x's, so I have 5 x's and another 3 x's, I can add those together to get 8 x's. When we look at maybe say non-integers, so things that have decimals in them like this, we can do the same thing. So if I have 2.1 x's and 0.3 x's, I can add these together. And I'm going to add an extra step in here just to make sure that we see what's going on. Here, I'm going to take 2.1 and I'm going to add 0.3 x. So this is how many x's I have. It's just the 2.1 copies of the first one and the 0.3 copies of the second one. And if I add those together, and again, you could just use a calculator for this if you wanted to. I did this ahead of time. This is just going to be 2.4 x's. So again, when we're adding multiples of x's, we just add the numbers out front to get exactly what we want. So let's do a couple more. If I've got 5 x's and I want to subtract 2.7 x's, this works in exactly the same way. If I had 5 apples and I take away 2.7 apples, I'm left with some number of apples. So again, what I'll do is I'll take the 5, I'll subtract 2.7, and this is how many x's that I'll have left. This is something I can do, for instance, in a calculator. So I can go 5 minus 2.7. I hit enter, and I get 2.3. So here I'll have 2.3 x's. And then if I have 1.6x minus 0.09x, again, the x's are exactly the same. This is subtracting apples from apples, for instance. So if I had 1.6 of them and I'm subtracting 0.09 of them, I'll be left with, and again, we can just plug this into a calculator, 0.07 x's at the end. So I will use this in some other examples in the next video.